Here is a specific insight about modern nutrition. We will spend some time today insisting on the evolution on the classical nutrition towards modern nutrition as an adaptation to new challenges. So I'm Pierre Le Breton, working for Lallemand for since last year as a global technical manager for monogastric. And I'm coming from the feed industry. I've been working in the feed industry for more than 26 years, and I've been lucky to spend those time in the global adaptation of this feed industry towards something more accurate, something more related to the global requirement of animals. When it's come to speak about classical nutrition, which is, let's say, apply everywhere in the world, we are mostly describing raw material, let's say, a profile on the digestible with a digestible angle. So most of the time we are focusing on the what is digestible fraction coming from protein, energy, minerals, sometimes fiber, antioxidant, and all the trace mineral and vitamins. And that's it. So it happens, and it's been describing in a matrix. It's coming from quality control, performance checking, on the way to accuracy, but most of the time not enough. This classical nutrition usually is meeting the animal requirement. That's classical nutrition. We want from nutritional input be able to face the requirement of the animal to achieve maintenance and growth with an economical benefit. Globally, this approach, we know from experience that this approach is not good enough, because our animals are produced in a complex environment involving a lot of different pressure that can usually are external, like the genetic evolution, antibiotic reduction, zinc oxide ban, so this kind of societal pressure, but also some related to the environment, like the heat stress, also some raw material specificity that will make this balance between requirement and national nutritional inputs not that clear. And at the end, we will face technical problems and sometimes economical problems. That's why it is not sufficient. We need to go for something more accurate with a better global control and make the link between nutrition and health. It means that in front of those two main, let's say, criteria confrontation, we know and we see from animal behavior and animal performance expression, we see that sometimes something else is happening that can be positive, and something that makes from the choice done in the field that will have positive impact more than expected from the classical nutrition, or at the opposite, some negative impact coming from the feed composition. That means the feed is not expressing what has been expected, what has been, let's say, calculated in the animal. Something else is happening. That makes this classical nutrition not enough, not accurate enough to be able to express what the feed will operate inside the animal. So if we go a little bit, deeper in this concept, in the requirement of the animal, it's a matter of course, age, weight, genetic quality, physiological stage, activity, but also everything related to the environment, the stresses, temperature, hierarchy, also the light, the wind, the floor quality, a lot of, let's say, components that will influence maintenance, but also the ability for growth of the animal. That's global requirement. And the other side, what will come from the nutrition is, of course, the water with quality and quantity, and everything related to the feed, speaking about quality, regularity, composition, digestibility. That means also the impact of process or processes on the digestibility of the animal. What are the non-digestible fraction of the animal? What are the anti-nutritional factors coming from the raw materials, the chosen raw materials? What are the contamination? What are the physiological efficiency of our animal? So, and at the end, what are the quantity? So those nutritional inputs are quite complex, mixing quantitative, let's say, information, but also accurately qualitative information. And in the middle, we have many so-called variation factors that will change, that will make the relationship between requirement and nutritional input a bit different. And those variation factors can come from management, from biosecurity, for skills that will also modify the expression from the animal. It can come from housing, of course, heat stress, temperature, light, density of animal, those components related to the housing. But it can also come from, let's say, more health side, coming from veterinarian. What are the medicine applied to the animal? What are the level of vaccination? Do we apply some hormones? So those components inside those variation factors will affect the expression of the feed. And then economically, we will have the level of performance, we will have the regularity that are all involved at the end in the economical expression of the nutrition. So because of those variation factors, because of the complexity, the global complexity of our animal expression, we are step by step going from classical nutrition, again, expressing what is mostly digestible, to a more modern nutrition, more complex. It's really a new approach, but in front of, we keep what is digestible, but in front of this, what is digestible, let's say, expression, we want to explore and to express and to control the physiological impacts of the feed choices, of all the nutritional choices that has been done in the feed. This modern nutrition is not only related to the digestible fraction of what is coming from raw material choices, it is something much wider, a global approach that will make the link between the choice I am doing on my feed and how my animal will globally react with those choices. In the middle here on this slide, we have this digestible characterization that, of course, still something important, central. And we have many nutrients that we can have to describe this digestible characterization of raw material and at the end of the feed. But we have on one side the physiology of the animal and how this physiology may impact the nutritional yield, the nutritional efficiency. It can come from the stomach efficiency with ABC4, the retention time. It can come from the small intestine, let's say, diversity in the microbiota. A lot of things will play on this physiological influential, let's say, expression. And we have one really specific area, which is the gut microbiome influential factors that will express from the quantity and the quality of the feed that will be applied. They will express what will happen on the microbial composition. the balance between bacteria, the global number of bacteria, the diversity, so abundance and the diversity, and then what will be the consequences on the feed efficiency. If we focus a bit more on this sector, it means that from the feed, the choice of raw material, the choice of feed ingredient, and the technology that will be applied on during the process, we will have, of course, let's say classical digestible nutrient that could be fixed, that could be chosen, but in the same time, those global choices will have an impact on the microflora. That means, depending on the feed composition, it will affect the quality, the quantity, and the relative composition inside the small and the large intestine, speaking about bacteria, speaking about microbiome. And because of this, it will affect the so-called gut barrier with all the functional property coming from the intestinal mucosa that come from external physical protection. It can come into local inflammatory response, and globally speaking, the impact on the global immunity system. Okay, so the choice that has been done on the feed will impact the physiology of the gut and the global impact of the gut on the animal. That means all this area was not directly taken into account in the classic nutrition. So it's a lot of information. It's a lot of different information. And we really need to organize those information together in order to have let's say, a more clear view, a kind of organization of all those components, global components of the modern nutrition. Again, we have our global diet, and we need to find a way through this prism in order to divide our global diet into several areas that will interact together. They are not completely separated, they are interacted together. And the proposal is to have three main areas. The first one is macronutrition. Macronutrition, very close to the, let's say, classical nutrition. What is digestible? What are the main components that will fill the global basic requirement of the animal? Net energy, protein, ideal protein, ideal fiber, phosphorus, minerals in general. We can consider they are in this macronutrition. The physionutrition, which is something that the classical nutrition is not expressing, this physionutrition is really taking into account what will be the impact of the choice on the physiology. What does it mean? It's more a matter of organ efficiency and organ impact directly on the animal efficiency in front of the quality of this feed. One example, it can be the retention time in the stomach, depending on the choices done on the raw material. Globally speaking, in the global diet, we will not have the same stomach retention time. That's an example. That's directly physionutrition. One choice, one impact. The micronutrition, the last one, is more related to the cellular efficiency. In this one, we will focus a bit more on the antioxidant, oxidative stress, some vitamin, and this kind of component, trace mineral, that will act directly on a cellular level. So if we cumulate macro, physio, micro, we have the full picture of the global impact of our global diet. We are not only focusing on what is digestible. We are also focusing on what is non-digestible, what are the side effects of my feed on the animal. And that's why they are all interrelated together, because physionutrition will influence macronutrition. Micronutrition will influence physionutrition, that will influence macronutrition. They are interrelated. So this kind of representation, which is basically very simple, it's for me one way as a nutritionist, when you are creating one feed, it's one way not to forget something, to have the complete picture and the complete ability to check point after point, steps after steps, that your diet is really, you are controlling the global impact of your choices. But it's also a way, an educational way, to have a global better control of your choice, and to have a better, let's say, explanation of the choice you are doing on your diet. So if we want to go a bit deeper in this concept, let's call it a concept. Okay, this modern nutrition, if we still divide it in those three interrelated areas, the first and the more important will still the macronutrition. It's kind of a nutritional skeletal. It is the basic. This basic will face the requirement that we can calculate through a factorial approach, for example. So again, in this macronutrition, we will find the net energy. We will find the ideal protein. We will find the right balance between the fiber, so-called ideal fiber, and the classical mineral requirement. In relation to this, the physionutrition, which is becoming more and more and more important, will take into account what will happen on the gut microbiota. My choice, the impact on the gut microbiota. What will be the impact on the animal behavior coming from this? Okay. What will be the level of inflammation? Okay. What will be the impact on constipation? What will be the impact on glycemia, insulinemia, and all the hormones impact that we can also forecast from those choices? So a lot of different impacts, mostly done on organs, if we consider that the gut microbiota is an organ, and the relation to macronutrition. And the last one, micronutrition, as I say, as a cellular efficiency. So in this box of macronutrition, we may have a look and we may focus on, let's say, specific oxidative stress, and with the impact of trace mineral, with the impact of selenomethionine, with the impact of all this global strategy that will have a cellular impact. The same for vitamins, and all, let's say, the cellular protection. So one macro, second physio, third micro. In this kind of hierarchy, first have a look to the macronutrition, then complete it with the physionutrition, and at the end, we finish with the micronutrition. And if it comes to the formulation, very practically, when we are making a feed, we have some matrix descriptions with some nutrient, but we also have some, for example, process steps to achieve or not in order to face the requirement we are looking for. So we have some nutrient related to directly the composition. We have some specific requirement related to fiber definition, some related to process, so the grinding, sometimes the heat process to the starch, for example, the anti-nutritional treatment, anti-nutritional factor treatments, or the mixing quality. And we have what is related to physical property, for example, with water holding capacity, the buffering capacity, or the electrolytic balance. Those global components are enough to make this description between macro, physio, and micronutrition. And if we put it the same nutrient organized between macro, physio, micro, we will have what you have on the slide. This nice composition, easy to check, easy to fill first to the first level of nutrient that will face a requirement. The second one, the nutrient that will be exactly facing physiological impact. Okay, and the third one, the orange one, the one related to micronutrition. And we can take some direct example. Here, I kept one with gilts. When you want to create a gilt program, including several feed, we may have this macro, physio, micro nutrition organization, and then you will be able to put your choices, your targets in nutrient between those three main areas. That's easy. It's just a matter of organization. And then you may check that you will forget nothing and you will not have double impact on one criteria. It's also one way to have efficiency with the lower cost choices, the lower cost strategy. Here we are. It's nothing really special. It's mostly a matter of organization of this new tool for describing nutrition. We are in a very complex area. Animal nutrition is becoming more and more complex, and it is multifactorial. And we cannot stay only focusing on macronutrition, especially because we are, let's say, extracting a lot of security, like antibiotic, like zinc oxide, that were able to limit the physiological impact of the feed. That means today, we really need to understand and to organize a complete description that will help to express, control, I should say, to control what will come from the feed choices. And here our proposal is to have this description between macro, physio, micro. That's already a lot of nutritionists are already applying. That means all raw material, but also feed ingredient should be defined in this global representation and with a hierarchization into it. Just to take an example within the Lallemand product, if we focus on the Boulardi, on the Levusel SB, we will have a nice impact on the physiological nutrition, okay, mostly acting on this specific organ, so-called the gut microbiota, with a lot of different physiological impact, but also an impact, for example, for gestating sows on the release of net energy coming from several reasons, but mostly from the fiber valorization. Then it will change the macro valorization with a higher release in net energy. So an example, Boulardi will both act on physio nutrition, but with the consequences on the macronutrition. Hope this description was clear enough, and thank you very much.